We are on the page 9, section 5.4. Let's see some examples. How we are going to use the systems of equation to solve some apps problems. We are on the page 9, section 5.4. Let's look at the first one. So this week we have been talking about that. Talking about what, right? Solving the systems of equations. 2 by 2, 2 variables and 2 equations. Then see how we can find the answers. So let's take a look at the first question. Michelle has 4 times as much money in her saving account as in her checking account. So she has 2 accounts. And she has what? One is saving, right? One is what? Checking. Then she has money 4 times in her saving than in her checking. That's what it says. Then we know the total amount of money she has is what? $2,300. She total has $2,300, right? Find the amount in her saving account, and we'll try to find both. So we wonder what's in her saving, what's in her checking, right? In her saving, she might want to save it. If my friend Michelle, then, we might spend some of her money on checking to have a treat, right? So how should we do that? How many things we don't know? 2 things, right? Then we need 2 equations to solve it, 2 by 2. Then we know 2 accounts, and what other information we have is she has what? 4 times in saving than checking. So we can do this way. Okay, for her saving, we say, okay, make us a C, make us S. Checking would be the C, right? So it says total is $2,300. So what should we do? Saving plus checking is what? 2,300. That's one equation. Another equation is what? Saving is 4 times of checking. So we can have saving equals 4 times of checking. Sometimes you write C equals 4S. Which one you think we should use? If checking is 100, 4 times saving would be 400. Like this one, if checking is 100, 4 times saving will be checking. That means what? Saving only has $25. So that's not right. So saving is 4 times of checking. You need to write it this way, right? So what do we have? 2 variables, 2 equations. Then we say the method we have learned, we had 3 methods, right? Which 3? First one is graphing. Second one was what? Substitution. Third one was what? Elimination. What do you think of which method you will use for this problem? It looks like you already have 1 variable by itself. It seems you can do what? Substitution is quicker, right? So you substitute S. It's same thing as 4C. So you will replace S with 4C. So that will be what? 4C plus C would be 2,300, right? After the substitution, you end up with what? 1 equation, 1 variable. Instead of 2 equations, 2 variables. So we make a situation simpler. So you simplify. to solve it. Next class, the next course, Math 154A, you will do 3 variables, 3 equations. But we start from here. Previous course, 152A, what did you learn? 1 variable, 1 equation. This class, we learn 2 variables, 2 equations. Next course, 3 equations, 3 variables. Getting higher and higher. So now we come back to simpler form. So we have 5c equals 2300. Then you divide it by 5. So your c is what? 460. 460 of what? Goats? $460? So we are talking about dollars. So that you need to write it down, the what? The unit of measurement. So if you're a C, what does C mean? C means what? Your checking account, right? Then what's in your saving? What do you think? You plug back in. Saving is 4 times that much. So you times 4, that would be 1840. Right? One is 4 times of the other. Then you also check. How do you check? You put them together. So total would be 2300. That's how you check. That's how we apply 2 by 2 to solve a problem. Let's look the next one. It's on your page 9, right? So admission prices at the local weekend fair were what? $5 for children and $7 for an adult. So after a day, you collect the money is what? Total you collect $33.79, right? Then you sold so many tickets, 187 people, so many tickets. So that includes what? Both adult and children. The question was, how many children and how many adults attend the fair? So you wonder, at the end of the day, you have so much money, you have so many tickets you sold. You wonder, how many adults, how many children? So if you have more children, then you might plan your fair next year differently, more popcorns, more cotton candies, as such, right? So how you can figure out? How many things we don't know? 2 things, right? So we say, okay, we want to find out how many adults and how many children. So we say, okay, I have C is what? Number of children, right? I can use what? A equals number of adults. 2 variables, you need to make 2 equations. How do we make 2 equations? If each child is $5, if you have one person, you have $5, right? If you have 2 persons, you have what? $10. If you have 500 people, how much you will have? 500, right? If you have X people, how do you get 5, 10, 500? You multiply how many tickets you sold for the children, right? If X children, each one is how much? $5, you should have 5X. Is that right? Same thing for the adult. If each person is 7, one person, you will have $7. 100 people, you will have what? 700, right? X people, how do you get those numbers? You multiply by 7. So you should have what? 7X. Now take a look. We say number of children is what? C. Each one is $5. C of them, you will do what? 5C. 5 times C, 5 times X, right? And number of adults are A. So 7 of them, you should do what? 7 times 1, 7 times 100, 7 times X. So now you have A, so you do what? Plus 7 times 8. So total is how much you receive. That's the money from the children. That's the money from the adults. So total you should have $33.79. Right? So that's one of the equation. Another one is total you have 587 tickets you sold. So that means what? Total with C and A, children and adult, total is what? 587. Then you clear, right? And when you write the two equations, one is the money, one is the tickets. The measurements are different. Internal meanings are different. But when we write it down, they are only numbers, right? But the meanings behind the equation are totally different things. So right now we have what? 2 variables, 2 equations. How should we do? So usually we use addition method, elimination addition method, or we have what? Substitution. Which one you think you will do? Looks like elimination is better because you don't have to move one variable by itself. So what do you think? You want to eliminate C or eliminate A? Looks like C is simpler because you only need to multiply 5 instead of 7. So I'm going to multiply this by 5. So what do I have? 5C plus 5A equals 587 times 5. That would be 2935. However, if you add it, you cannot cancel the 5C and 5C. We say when we cancel, what do we need to do? We need to do the opposite sign. So that's negative. So we should multiply by negative, negative, and negative. Is that right? So that's your second equation. Then you will rewrite the first equation. Then curly is a formal symbol of math. Means you work off these 2 equations together. They are a system, right? So you will add elimination by addition. So you add those, that would be 4, 4, 4. So your A would be what? Divided by 2. A is what? 2, 2, 2. What is 222? $222 or goats? Not really. What is your A? You have to go back, see how do you declare what's your A. A means what? Your number of adults attending fair, right? If A is 222, you need to find the C. How many children? How do you find the C? Because total is what? 587. So you do what? 587 minus 222. You end up what? 365. So 365 of what? Dollars? No. Right? Is number of children. That's how you do it. Got idea? Let's look at the problem C. It says, last month, Jerry Papa purchased 5 DVD. He purchased 5 DVD, right? And 2 CDs at the store. Total, how much it cost him? Total is $65. And this month, he bought what? 3 DVDs and 4 CDs. Total is what? $81. Then we wonder, if I just want to buy 1 DVD, how much it would cost me? If I just want to buy 1 CD, how much it would cost me? Right? So we want to find the single price, find the price of a single CD or DVD. So how should we start? First, you declare the things you want to find. So for one thing we want to find is what? Identify them, right? We want to find what? The price of the CD, right? So we say, okay, I call it C. Then I also want to find out a price of DVD, so I call it D, right? 2 variables. But we need to write 2 equations. So 5 DVDs and 2 CDs is what? 65. How do you write? 5 DVDs, right? Each DVD is $D. 5 of them, you would do what? 5D, right? Like 5X. If each CD is $C, then 2 of them would be what? 2C, right? 1 would be $C, 2 would be $2C, 3 would be $3C, 2 of them, 2D. Total is what? 65, right? Same thing, we should be able to write the second one. 3 DVD, each one is $D, 3 of them, 3D. For CDs, each one is what? $D, and 4 of them you times 4. You plus together would be your total $81. So, do we have 2 variables, 2 equations? And which way we want to resolve it? Elimination or substitution? It looks like elimination much easier. Okay, this is not 4D. So 3 DVD, 3D, 4 CDs should be what? 4C, right? So then what do? Looks like you want to eliminate C or D. Which one is easier? For D, you need a 15 LCD. For C, between 2 and 4, you only need a 4, right? So we multiply this by its opposite to 4. It's -4. So we multiply by -2. So you distribute, you have what? 10D minus 4C equals what? -130, right? Then you will rewrite the second one together and curly it. So you know these 2 work together. Then what do? You add them. This cancel out. So we have -7D equals, you subtract them, then the sign is what? Negative, right? 9 and 49. Then divide both negative, right? -7, so D is what? 7. What is 7? $7, 7 goats. D is what? Go back to check the price of the DVD, right? So your first step is always what? Identify things needed. With how many variables? For this class, 2 variables, right? Then second one, you will write your equation, right? Then third step, you will what? Solve it. That's the thinking process. Then D is what? Go back to check the price of a DVD. So it's dollars. Then what is your C for CD, right? You plug in any equations. Okay, so if I plug in the first one, 7 times 5, 35. So it's 35 plus 2C is 65. Then you minus 35 on each side. That would be 30. 2C is 30. C is what? 15. Right? So each DVD would be $7 a piece. For CD, it would be $15 a piece. Let's look at the next one. Problem D. That would be on your page 10. It says, during the 2006 regular MLB season, Ryan Howard of the Philadelphia Phillies hit the most home run of any player in the major leagues. Over the course of this season, he hit 4 more runs than David Otis. So what are we talking about? Ryan, we have how many person? We have Ryan and who? David, right? And together, those batting gains total 112 home runs. How many home runs did each player hit? First, decide what was the question. The question was how many home runs each one hit, right? So we need to identify them first. So first, you identify them. Ryan is how many? Ryan will hit number of home runs, right? By Ryan. Then, we don't use Ryan. We use what? Number of home runs for Ryan, we use R, right? Then number of home runs for David, we use what? D, so we can tell who is whom. Then next one, what should we do? We write the equation, right? So look at the condition it's told on your question. Over the course of the season, Ryan hits 4 more runs than David. Ryan's hit 4 more runs. So who has more? Ryan. Dave has less. So if you do Dave plus 4, is that the home runs for Ryan? That's how you write, right? Dave's and 4 more runs to Ryan, right? Then also total, they have what? Total is 112 runs. So how do you write that? Total means what? Both. You do what? D plus R is what? 112. Is that right? Then you curly it. What do you think to solve it? Do you use substitution or elimination? Looks like substitution would be easier, right? So you can just plug in for R because R is already by itself. So you can replace R with D plus 4 because they mean the same thing, right? So what do you have? D plus 4, that's R, become 112. Then how do you solve it? Combine like terms, right? Then you minus 4, 2D is what? 108. So divided by 2, so it's 54. What does 54 mean? Dollars? Goats? Not really. You need to go back. Take a look. What does D mean? D means what? The number of home runs for David, right? So that's the home run. Home runs. If so, then what's the home runs for Ryan? Ryan should be what? 4 more. So you plus 4, that will be 58 home runs. Total, you add them together to check, that will be 112 runs. Right? So that will be section 5.4 for the apps. We just wanted to show you how to use 2 variables and 2 equations to solve problems. Then you say, oh, who should I care? Yes, you do, because it means what? Dollars. You can use these skills to apply to the job, right? I used to do 6 by 6, 6 variables, 6 equations to do the satellite trackings. So we use second year's calculus, partial differential equations to solve it. So it has a lot of applications, but it's not for you right now. Then you need to learn more and to figure out how to apply it. So we just started. So get used to it to solve 2 by 2. However, for this section 5.4, you don't have homework. Just let you get familiar with the methods first. Okay? So that would be the section 5.4 for chapter 5. So you have homework due this week. For the first week, you need to catch up. I mean, you need to keep up. Otherwise, it's hard for you to make it. Okay? Week by week, you need to keep up with the homework. Then homework is due next Monday, 1 p.m. And how we will grade you, and if you're late, it's all written on your syllabus. Take a look.